Then a field eligible for what primary key is called candidate key. Okay, na? The field eligible for primary key is called candidate key. Like, see this example. Example. Suppose I want to store. Okay. Then you know RTA, Road Transport Authority. They maintain database. Yes or no? Huh? What database? Vehicle database. Okay. So every vehicle information is stored in what's it? RTA database. Okay, now every vehicle information is stored. Suppose vehicle information is stored in one table. The table is a vehicles table. In vehicles table, they store what's it? Vehicles data. So what is stored? Vehicle number, vehicle name. Next one, vehicle what's it? Model, vehicle what? Cost, vehicle what? Okay, na? So vehicle cost, vehicle chassis number. Yes or no? Huh? Every vehicle has got this. You know, na? Chassis number. Okay. Vehicle number, vehicle name, vehicle mode, vehicle cost, vehicle chassis number. Okay. Then, so in this table, so what is primary key? Huh? So, what is the primary key? Vehicle number is eligible for primary key. Chassis number is also eligible for primary key. Okay, na? This is eligible for primary key. This is also eligible for primary key. No two vehicles have two same chassis number. No two vehicles have same vehicle number. Okay. So both are eligible for what's that? Primary keys. They are called candidate keys. So vehicle number is one candidate key. Chassis number is one candidate key. So both are eligible for what? Primary key. Okay. But when you want to create this table in database, but database allows only one primary key. That means from these two, one should be selected as what? Primary key. Okay, na? So because database allows only one primary key, select only as primary key. I selected what's it? Vehicle number. Vehicle number as primary key. Understood? I selected vehicle number as primary key. When vehicle number is selected as primary key, then so what is chassis number is called? Chassis number is called what's it? Chassis number is called alternate key, or what's it? Or you can say secondary key. What is chassis number is called? Alternate key or secondary key. Chassis number. Then both are eligible for primary key. From these two, one is selected as primary key. What is the other one is called? Alternate key or secondary key. Okay, now then. So sometimes secondary key is also important. Okay, now secondary key is also what's it? Important. When primary key value is not available, data is accessed through secondary key. When primary key value is not available, data is accessed through secondary key. Example, okay, na? Then suppose vehicle is stolen. Okay, na? Vehicle what's it? Stolen. Someone stolen the vehicle. Okay, they can change what's it? They can change the number plates or they can remove the number plate. Then how police department will identify the vehicle? By using what's it? Chassis number. When primary key value is not available, so data is accessed through secondary key. Okay, na? Then suppose like I went to bank, okay, na, for some inquiry, went to the bank. So they asked what is my account number. Okay, na? Suddenly I didn't remember I didn't get my account number. I forgot my account number. Okay. Then okay, they asked, tell me your registered mobile number. Okay, now actually in database, account number is what's it? Primary key. Okay, now? But when primary key value is not available, so data is accessed through phone number, secondary key. Understood? So sometimes this is also important. But at the time of creating the table, how you declare the secondary key? At the time of creating the table, how you declare the secondary key? Is there any keyword called secondary key? Primary key keyword is there? Yes, you declare primary key. But can we declare the secondary key? No. So how you declare the secondary key? By using unique and not null. You understood? How to declare the secondary key? Unique, not null. So any column declared with unique and not null is called secondary key. Okay, then. So secondary keys are declared like while creating what's it? While creating tables, while creating table. So secondary key, secondary keys are declared with what? Unique, not null. Okay, then. So there is no keyword called secondary key, but how secondary keys are declared by using this unique and not null. Then that's the next one. What the next one is? Next one is what's it? What the next one is? Check. Okay. Next, check. So if you see the previous rules, you see the previous rules. All these rules are what? Three. You know, three. Unique, not null, unique, primary key. So these rules are based on duplicates and nulls. One is nulls are not allowed. One is duplicates are not allowed. One is duplicates and nulls are not allowed, like that. But always rules based on duplicates and nulls only. No, sometimes rules based on condition. Sometimes rules based on what? Condition. Value should be greater than 1000. Value should be between 5000 and 10,000. Value should be this. Okay, na? So sometimes rules based on what? Conditions. When rule based on condition, then use what? Check constraint. Always rules not based on what? Not only based on duplicates and nulls. Sometimes rules based on conditions. When rule based on condition, then use what's it? Check constraint. Then what? Use check constraint when rule based on what? Okay, you check constraint when rule based on condition. How to declare the check constraint? Like this. Check. So check constraint is always declared with what? Condition. Okay, na? So when you declare the check constraint should be declared with condition. Let's take one example. Let's take one example. Okay, then. So I want to declare a rule. What that rule is? There is a rule. Salary must be minimum 3,000. Okay, na? In one company, one organization, so they have a minimum salary. Salary should be minimum, what's it? 3,000. Salary must be minimum 3,000. I want to declare this rule. Okay. Then what? But this rule, if you see this rule is not based on duplicate. This rule is not based on null. It is based on what? Condition. So create table. Suppose EMP something 13. So one field is what? EMP ID integer. EMP ID integer. Then this is what? Employee ID is primary key. Next one, name. Name is what? Varchar of 10. This is not null. Next one, salary. Salary is what? Money. But there is a rule for salary. What the rule is? Minimum 3,000. How to declare this rule? By using check. So write the condition. Okay, na? In check constraint, you write condition. What the condition is? Salary should be greater than or equal to 3,000. Okay, na? Then greater than 3,000. Greater than or equal to 3,000. So create this table. Create this table. Then so table is what's that? Created. Okay. After creating the table, now insert the data. After creating the table, what's it? Insert. Insert into what? insert into EMP13 values. So number is 100, name is what? A, salary is what? 1000, salary 1000. I'm inserting salary 1000, but salary column is declared with what? Check constraint. So salary should be greater than or equal to 3000, but given salary is what, sir? 1000. What this command gives? Error. Insert statement conflicted with what? Check constraint. Okay, na? So there is a conflict with check constraint. Okay, then. So what is this gives? Error. Then. So next, insert into then. Insert into EMP13 101. Name is what? B. Salary is 5000. This is accepted. Yes or no? Yes. So then this row is what? Created. One row affected. Suppose, for example, insert into 102. Name is what? 102. ID. Name is C. Salary is null. Then salary is null. Allowed or not? Null value. Okay, na? Null. Null is allowed. Null is what, sir? Allowed. Okay. Then check constraint allows what? Null value. Null means you are not entered the salary. Null means what? It is not zero. Null means you are not entered the salary. If you don't enter the salary, okay. But if you enter the salary, then it should be greater than or equal to 3000. Understood or not? If you don't enter the salary, accept it. But if you enter the salary, then salary should be greater than or equal to 3000. So check constraint allows null values. Okay, na? Nulls are allowed. Then so check constraint allows what? Nulls. Understood? Okay, now null means absent. If the value is absent, accepted. If value is present, then it should be greater than or equal to 3000. Understood? So check consent allows what, sir? Null value. But you don't want to allow null values. Then you don't want to allow null values into salary. Then so declare not null. Declare what, sir? Not null. Okay, na? Then that's the next one. Second. Then so let's see second one. Okay. Just you tell me, for example, there is a rule. What the rule is? Gender must be M comma F. Then gender must be M comma F. Then so see, one example I given table creation. At the time of creating the table, how to declare the check consent, I given one example. Now this one, gender must be M comma. Tell me only like this, declaration of gender, not the complete table. So just tell me the declaration. Gender care of one check 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 gender uh, equal to M or gender equals to F. Okay, na? Then instead of, see, you can write like this. One second. Or gender equals to F. If it is M, accepted. If it is F, accepted. In these two characters, if any of the character is entered, accepted. So or. Otherwise, you can write like this. What? Gender in then M. M comma F. Gender in. Okay. M comma what's it? F. Instead of writing gender equal to M or gender equal to F, instead of writing 2, then you write what's it? Gender in M comma F. Okay, na? Then understood. Next one. Third. Suppose you go to ATMs, enter the amount. Can you withdraw 2,255 rupees? No. What is the rule? Suppose there is a field amount. Amount must be multiple of what's that? 100. In ATM, that amount should be multiple of 100. Yes or no? Then how to declare this? Amount, then money, then check. Uh, uh. How do you know this amount is multiple of 100 or not? Divide amount with 100. Remainder is 0. Amount modulus 100 equal to 0. Amount modulus of 100. So divide amount with 100. Remainder is 0. Okay. Then next one. Next. Suppose this is one. Next. There is a call. What's it? Password. Password must be minimum 6 characters. Then password must be minimum 6 characters. What? Yeah. Password what? Varchar. Password varchar of 10. Check. Then password greater than or equal to 6. No. 6 is not password. 6 is not password. What is 6? Number of characters. Number of characters should be minimum 6. But password is not minimum 6. Password length should be minimum 6. Don't compare password with 6. Password is string. 6 is integer. Yes or no? Then what we have to compare? Length of password should be greater than or equal to 6. Okay, na? The 6 is not password. The 6 is what? Length of the password. So password length should be minimum 6. So length of the password should be greater than or equal to 6. Fifth one. Then what? Suppose there is a condition. What that is? Email ID. Email ID must contain what's that? At the rate. And email ID must end with what? .com or .co or .in. Then so it should contain at the rate symbol. It should end with .com, .co, .in. It should end with any of these three. Okay. Then how to write? Email ID varchar of some 20, 30 like. Okay. Check. Check what's it? Check email ID. Email ID. Then first rule is should contain at the rate. Then email ID like what? Percentage what? At the rate percentage. Okay, na? Email ID like percentage at the rate. Next what? End. It should contain at the rate and it should end with any of these three. Next what? Email ID. Then like percentage what's that? .com. End with .com. Yes or no? Next one. Or email ID like what? Email ID like percentage.co. Next one. Or email ID like what? Email ID like percentage what? .in. Okay, na? Then so close brackets. That's see when we use like comparison with value in operator, comparison with pattern like operator is not given value, is given pattern ending with com, ending with co, ending with in. Then you have to use like. Understood that. Okay, na? That's all. So these are the what, sir? All these are what? Examples. Examples of check and sign. Salary should be minimum 3,000. Gender must be M comma F. Amount must be multiple of 100. Password must be minimum 6 characters. Email ID must contain at the rate. Must end with any of these three. Understood that? Okay. So what the next one is? Next one is what's it? Foreign key. Okay, now foreign key. Then next. Okay, now so foreign key. Then so next one is foreign key. So what is foreign key? What for foreign keys? Okay, then so foreign keys used to establish what relationship between two tables. So what is foreign keys for? Foreign keys for to establish the relationship between two tables. Okay, then so now let's see actually why you establish the relationship. Okay, na? So why you want to establish the relationship between two tables? Let's see this. For example, I created, okay, na? I created one table. I'm storing the data like this. I'm storing the data like this. Employee ID, name, salary. But in companies, employees works for what? If you take software companies, in employees works for projects. Employees works for what? Project. The employee working for which project? What is the project ID? What is the name of the project? What is the duration of the project? What is the okay project? Who is what is the cost? Okay, na? Duration. What is the cost of the project? So who is the client for that project? Okay. So I'm storing the data like this. I designed one table. In the table, I'm storing the data, employees data and employee work for which project, that project details. Suppose there is an employee one, A, his salary is something. He joined in project 100. Okay, na? Is working for project 100. Some project name, ABC. Duration is 5 years. So cost is suppose some 400 crores. Who is the client for the project is some Tata Motors. Okay, na? Next one. Another employee. Employee 2. Name is B. His salary. Some salary. And this employee also work for the same project. This employee also work for the same project. Yes or no? Yes. He is also working for the same project. Okay, na? Then same 400. Next one. Same client, na? Project is same means like that. Employee, there are 20 employees. All the 20 employees are working for what's it? Same project. All the 20 employees are working for same project. Okay, then understood. So for all the 20 employees, this data is what's it? For all the 20 employees, this data is what? Repeated. For all the 20 employees, these details are repeated or not? Yes. What is this is called? This is called redundancy. What this is called? Redundancy. Repetition of data, duplication of data. This is called redundancy. Okay, then. So if table contains redundancy, the problem is memory wastage. But memory wastage, the problems are updation is a problem, insertion is a problem, deletion is a problem. Suppose now they want to change this duration 5 years to 6 years later. Initially the 5 years, later they want to change this duration 5 years to what's it? 6 years. 6 years, 5 years to 6 years. Then how many rows you have to update? Huh? How many rows you have to update? 20 rows. How many rows you have to update? 20. 20 rows you have to update. Yes or no? So this is there 20 times. You have to update 20 rows. Yes. Updation is a problem or not? Yes. Okay, na? Then suppose, for example, I want to insert new project. I want to insert new project 105. It is just okay, na? Recently started, but no employee joined in this project. Can you insert the new project details without employee ID? Because in this table, employee ID is primary key. Can we insert the data without the primary key value? No. So insertion is a problem or not? Yes. So we cannot insert new project without employee. Okay, na? Then. So next, suppose for example, then here, if I ask you, what is the project undead details means? Can you give the details of project undead? Can you give the details of project undead or not? Yes. Suppose this employee is resign. When this employee resigns, then what you do? Delete. Okay, na? Next, delete this employee row. Now I'll ask project undead details. Can you give the details? Yes. This employee also resign. You delete the row. Okay, na? Now I'll ask project undead details. Can you give the details? Yes. This employee also resign. Okay, na? This employee also what's it? Resign. So you delete this row. Now I'll ask project undead details. Can you give the details? No. Because along with the employee's data, project details are also deleted. Understood? Now you cannot give this then. So deletion is a problem or not? Yes. So if table contains redundancy, so insertion is a problem, updation is a problem, deletion is a problem. That is why what SQL server, every database system says what? Don't store the data in what's one table, store the data in multiple tables. Don't store the data in what? One table. Store the data in what? Separate tables. Store employees data in what? Employee table. Project data in what? Project table. Store the data in its own table. Store the data in its own table. Employee data should be stored in employee. Project data should be stored in project table. But what you are doing? You are storing project data in what's that? Employee table. That's why it leads to what? Redundancy. Okay, na? Then. Understood? So then what you have to do? Now divide this table into what's it? Divide this table into what? Two tables. One table is what's it? Projects. Project ID. Project what's it? Name. Project what? Duration. Project cost and what's it? Client. So project is 100. Suppose like 101, 102. Suppose there are three projects. Okay. Then there are three projects. Duration is 5 years. Cost is some 400. 400. So client is what's it? Data. Next one. Suppose 101. Suppose KLM something. Okay. Next one. Suppose 3 years. Some okay na 300. Suppose some bank is there. Okay. Suppose DBS bank something. Next one 102. Okay na some project some 2 years like this. So this is what okay na this is next. So there are three projects. Next, who works for the projects? Employees works for the project. Employee number, name, salary, like this. So employee 1, 2, 3, like this. Okay. Then so what I'm doing? Huh? Dividing the table into what? Two tables. Dividing the table into two tables. In one table, what's it? In one table, I'm storing what? Projects data. In another table, I'm storing what's it? Employees data. Okay. Then so divided the table into two tables. Okay. Then now this project details are stored how many times? One time. This project details are stored how many times? One time. But in the previous, the project details are stored how many times? 20 times. Yes or no? But here only how many times? One time. So redundancy is reduced or not? Yes. Okay, na? Then you are storing the details only one time. But after dividing the table into two tables, what is missing? Okay, na? After dividing the table into two tables, what is missing? Huh? What is missing between these two tables is relationship. What is missing? Relationship is missing. Now I'll ask here, this employee belongs to which project? Can you answer? Yes. This employee works for which project? Can you answer? Yes. Now I'll ask, this employee belongs to which project? Can you answer? No. That means after dividing the table into two tables, what is missing? Relationship between these two tables is missing. I want to establish the relationship. Then, so to establish the relationship between two tables, introduce foreign key. Introduce what, sir? Foreign key. Introduce foreign key. Introducing foreign key means take primary key of one table, add that primary key to another table. Okay, na? So between these two tables, establish the relationship. To establish the relationship, take primary key of one table, add that primary key to another table. So in this table, what is primary key? Project ID. So take this project ID, add this project ID to what's that? Employee table. So in project table, project ID is primary key. In employee table, this project ID is what's that? Foreign key. Okay, na? So between these two tables, to establish the relationship, take primary key of one table, add that primary key to another table. So in this table, what is primary key? Project ID. So take this project ID, add this project ID to employee table. So in project table, project ID is primary key. In employee table, this project ID is what's that? Foreign key. Okay, then. And okay, this is foreign key. Okay, na? This is foreign key. Foreigner. Foreigner means what? Foreigner means a person belongs to another country. Foreign key means a field belongs to another table. A field belongs to another table. Actually, this field is not belongs to, this field not belongs to what, sir? Employee table. This field belongs to project table. In employee table, so this project ID is foreign key. Okay, na? A field belongs to another table. Okay. But simply adding is not enough. So this is foreign key. But actually, what is the rule here? Suppose you enter 100. If you enter 100, what is the meaning? This employee joined in project 100. Project 100. Suppose I entered 101, means this employee joined in project 101. Suppose I enter, for example, 999. This employee joined in 999 project. Then tell me, this is valid or invalid? Invalid. Why? Because there is no project called what? 999. There is no project called 999. When project is not there, employee cannot work for this project. Yes or no? Okay, na? So that means this is invalid or not? Yes. What is the rule here? The rule is that the values entered into project ID should match with this values. This project ID value should match with project table project ID. Yes or no? 100 is valid or not? 100 is valid. Yes. 101 is valid. Yes. 102 is valid. Yes. 999 is valid. No. So because this project is not there, so employee cannot work for the project. Yes or no? So the values entered into project ID should match with project table project ID. Yes. Then what you have to do? Declare. Declare the rule. Okay, na? So what is the rule here? Foreign key. This is already after adding. This is foreign key, but this foreign key should be declared with a rule. What is the rule? What is the rule you have to declare? The values of this project ID should match with project table project ID. Then, so what you have to tell SQL server, when user enters project ID, go to the project table, check this value is there in the project table or not. If the value is there in the project table, accept it. If the value is not present in project table, don't accept. How to tell SQL server? By using one constraint. What that is? References. References. Which table? Projects table. Which column? Project ID. So you are telling SQL server refer the table. References means refer the table. Which table? Project table. Which column? Project ID. Suppose I enter 100. When I enter 100, then when I enter 100, SQL server go to the project table, checks 100 is there in the project table or not. Yes, 100 is there. Accepted. Next you enter 101. Enter what, sir? 101. When you enter 101, SQL server will go to project table, checks 101 is there or not. Yes, 101 is there. Accepted. Suppose you enter what, sir? You enter 10, suppose 999. 999. It will go to the project table, checks 999 is there in the project table. No, then it is not accepted. So this gives what's that error. Employee for D, suppose salary something for 100. 100 is accepted or not. So it will go to the project table, checks 100 is there. Yes, 100 is there, accepted. That means foreign key allows duplicates. Foreign key allows what's it? Duplicates. Okay, na? So because this employee belongs to 100, this employee also belongs to 100. Multiple employees can work for the same project. Yes. So foreign key allows duplicates. Employee 5E, suppose salary something 3000. This is null. Null. Okay, na? Null is accepted or not? Yes. Foreign key allows null values. Foreign key allows null values. If you enter null means accepted. If you enter the value, if you enter the project ID, then it should match with project table project ID. If you don't enter the project ID, okay. But if you enter the project ID, then it should be a valid project ID. Understood or not? If you don't enter the project ID, accepted. But if you enter the project ID, then it should be a valid project ID. So foreign key allows null values. Foreign key allows duplicates. The only rule is that the value of the foreign key should match with another table primary key. The foreign key value should match with another table primary key value. Understood now? That. So now next then. So what is this is here? What's it? Then above table contains what? Above table contains what's it? Redundancy. The table contains redundancy. Okay. Then the above table contains redundancy that leads to what? What is that redundancy leads to? Okay, na? Insertion problem, updation problem, deletion problem. They're called, what are they called? Anomalies. What are they called? Anomalies. Anomalies means like errors. You can say errors. What errors? Insert anomaly, update anomaly, delete anomalies. Anomalies means what? Errors. So above table contains redundancy that leads to anomalies. To reduce the redundancy, then divide the table into what's it? Divide the table into what? Two tables and establish relationship using what? Foreign key. Okay, then establish the relationship using foreign key. Then, so to establish relationship, take what? Primary key of what? One table and add it to another table as foreign key. Add it to another table as foreign key and declare with what, sir? References constraint. Declare with what? References constraint. To establish the relationship, take primary key of one table and add it to another table as foreign key. Not only adding is important, you have to declare with what? References constraint. Yes or no? Then. So to reduce redundancy, divide the table into two tables and establish the relationship. So to establish the relationship, take primary key of one table, add it to another table as foreign key and declare with references constraint. Example. This is the example. Okay. Then. Understood? Then. That's it. No. So that's why don't store the data in what? One table. Store the data in separate tables. Okay. Then. So this is next. Like after declaring, then what is the rule of the foreign key? Foreign key rule. Sir, up to now, unique rule, not null rule, primary key rule, check and sign rule, like this. What is the rule of the foreign key? Values entered in foreign key column should match with values of foreign key column. Foreign key column values should match with primary key column. Then, so what the rule of the foreign key is, values entered in foreign key column should match with primary key column. Okay, na? With values of what's it? Match with values of primary key column. Okay, then next, foreign key allows duplicates and nulls. Okay, then and after declaring foreign key, a relationship is what's it created between what a relationship is created between the tables, between the two tables, and what that relationship is called parent child relationship. What that relationship is called parent child. Okay, na? So after declaring foreign key, a relationship is created. What that relationship is called parent child. Okay, then so who is parent, who is child? First parent, then child. First parent, then child. Here primary key, foreign key, which is first? Primary key is first, foreign key is next, because always foreign key refers primary key, na? Without primary key, how foreign key refers primary key? Which is first, primary key na foreign key na? Primary key. First primary key, then foreign key. So primary key is parent, foreign key table is child. Okay, then so yeah, primary key table is what? Parent, and foreign key table is child. Okay, then understood now? Primary key table is parent, foreign key table is child. In our example, so which is primary key, which is foreign key table? Uh, Consider only common field, this one. Okay, na? So in project table, project ID is primary key. In employee table, project ID is what, sir? Foreign key. So this is parent. This is what, sir? Child table. Okay, na? That's all. So this is what foreign key concept. Uh, so to which table you added primary key? Which table you added foreign key? Which table? Uh, So, okay. One second. Sir, what is asking is, this is the project table. Here, what's it? Project ID, like some name, etc. This is what's it? Employee ID, employee name. So, like we added foreign key to what? We added foreign key to what's it? Employee table. Yes. Huh? You added foreign key to employee table. So what you are doing, taking the primary key of project table, adding this one. This, yes or no? Why not add foreign key to project table? See, once again, I do one thing. I'll take primary key of EMP, employee ID. Add this EMP ID to project table. In employee table, employee ID is primary key. In project table, employee ID is what, sir? Foreign key. Relationship is established or not? Sir, actually what I want is, I want establish relation between what? Employee and project. Employee and project. Okay, na? So then in this example, I taken the primary key of project table, project ID. That project ID is added to what, sir? Employee table. Yes. Okay, na? So why not this? Why not this? Why not this means take the primary key of employee table, add this primary key to project table. So in employee table, employee ID is project primary key. In project table, employee ID is what? Foreign key. Relationship is established or not? Yes. Okay, na? Then, but this is not correct. This is wrong. This is wrong. This is correct. This is correct. Adding foreign key to what's it? Employee table is correct. Adding foreign key to project table is wrong. How? Okay, now then that is you can like I can say in different ways also. One is what is the relationship between these two? Okay, now what is the relationship between what's it? Huh? What is the relationship between project and what's it? Employee. What the relationship is? One to many. What the relationship is? One to many relationship. How? One project, one employee, yeah, many employees. Many employees. One project, what? Many employees. Many employees works for one project. Okay, na? Then. So one project, many employees. Which is one side, which is many side. Which is one side, which is many side. Project is one side, employees many side. Always foreign key should be added to many side table. That's all. Project foreign key should be added to what? Many side table. Sir, understood na? Okay, na? Then. So if the relationship is one to many, add foreign key to which table? Many side table. In our example, so to which table you have to add the foreign key? EMP table. That's why I added foreign key to EMP table. Yes or no? Understood or not? Then I added foreign key to EMP table. What is the foreign key in EMP table? Project ID. Okay. Add foreign key to employee table. Understood. If the relationship is one to one, if the relationship is one to one, you can add foreign key to any table. You can add foreign key to project table or you can add project to employee table, any table. You can add foreign key to any table. One to many, many side table. Understood? Okay. We'll see that. We'll see that relationships. Wait. This is okay now? Understood or not? Then. Okay now? Then. Now, let's see the example. See, this is all theoretical. Okay, na? Theoretical. So practically, I want to create the tables. Then what? Create table. Which table you create first? Huh? Project table. So projects. What? In this one field is what? Project ID. So one field is project ID. Project ID. What? Integer. Then what is this is primary key. Project. What's it? Name. Name is what? Varchar. Varchar of 10. Next one, not null. Next one, what? Project ID name. What is the next? Uh, Name. Okay. Duration or client. Client is what's that? Varchar 20. Enough, na? Just three fields. Okay, na? Insert one or two projects. Insert into what's it? Projects where values. What? Project ID 100A. What is the client is? Tata Motors. Tata Motors. Then, so next one, 101, 101. B. Then, suppose then next some okay, na client, some bank is there. Let it be. Then, so create this table and insert this row. So table is what's it? Created. Table is created. After creating the table, then create what's it? Create table. What? Sorry, employee. Employee already there now. Let's say EMP project. Okay. Then table name because EMP table is already there. Employee ID integer. This is what? Primary key, comma. Next one. E name. E name is what? Varchar. Varchar of 10. This is not null. Salary. Salary is what? Money. I want to declare a rule. Salary should be minimum 3,000. Then check what? Salary greater than or equal to 3,000. So I want to store employee work for which project? I want to store which employee works for which project? Project ID. Then what is the rule for project ID? This project ID should match with project table project IDs. Then what? References what? Projects table project ID. Then That's all. Okay, now. So then let me create. Then so table is what, sir? Created. A relationship is established between these two tables. Now test it. Test the foreign key. I want to test the foreign key. And then what? Insert into what? Insert into EMP project values employee ID. What? Employee ID. What's that? One. Suppose common name is what? A. Salary is 5,000. Suppose project ID. Project ID is what, sir? 10100. So allowed or not? Allowed. One row affected. Now I'm inserting another row. Employee 2. Name is B. Suppose salary 4,000. Project ID is what, sir? Null. Null. Then allowed or not? Allowed. One row inserted. Next one. Uh, 3. 3. What is this is C. Then salary, what's that? 3,000. Then project ID is what's that? Again 100. Let's say, suppose then this is 900. 900. Allowed or not allowed? Not allowed. This gives error. Insert statement conflicted with foreign key. Okay, na? Then next one. Suppose, for example, then 4 employee 4 name is D, salary is something 4,000. So this is 100. Allowed or not? Allowed. So foreign key allows what, sir? Duplicates. Foreign key allows what? Null values. Okay, then. So the only rule is that the value should match with primary key. If it is not matching with primary key, it's not accepted. Understood? Then. So this is what error. That's okay, na? Then. That's all. So this is okay, foreign key concept. Okay, then next one. So then between the two tables, okay, what you did established what's the relationships. Okay, na? You established the relationship between two tables, and this relationships are what? Relationship what's that? Four types. Okay, what that is? One is what? One to one. Next one to many. Next one, many to one. Next one, many to many. So between two tables, there are four types of relationship exist. Okay, then. So this is 1:1. This is what? 1:m. This is m:1, m:n, mn. 1 1, 1m, m1, mn. Many to many. Okay, then. So four types of relationship exist between the two tables. Okay, then. Now, see, let's see. Suppose what is this is then, for example, then suppose this is what then, for example, this is table 1. Okay, now this is table 1. So this is, let's take this one. So let's say this is table 1. This is table 2. There are two tables, table 1 and table 2. Okay, then so table 1, and this is what, sir? Table 2. Table 1 contains what, sir? Suppose 3 rows, 1 2 3. Table 2 also contains 3 rows, 1 2 3. Okay, so this row is associated with this row. This row is associated with this row. This row is associated with this row. Okay, and what this relationship is called? 1 to 1. Okay, na? So one row in table 1 associated with another row in what's her? Table 2. So what this relationship is? 1 to 1. Suppose, for example, this is what's a table 1 and what is this is table 2. So this is table 1 and this is what's a table 2, table 2. And suppose here it is what's her 1 2 and here it contains what's her suppose 1 2 3 4. There are 4 rows. See here the first row, the first row in table 1 associated with these 2 rows, it is linked to 2 rows. The second row is linked to 3 and 4. What this relationship is called? One to many. Okay, then one to many. One to many, many to one. What? One to many and many to one. Same. Because if you see table 1 to table 2, what is the relationship? Okay, na? Table 1 to table 2, what is the relationship? Hmm? Table 1 to table 2, what is the relationship? One to many. One to many. Okay, na? Table 2 to table 1, what is the relationship? Many to one. If you see from one side, it is one to many. From other side, it is many to one. So both are what's that? Same. Next one. Next one. Let's see. This is suppose what is this is? This is table one. And what is this is what's that? Table two. So this is table one. Okay, na? So table one. That. So this is table one. This is what's that? Table two. Then. So this is what? One, two, three. Okay. Here also what? One, two, three. Then next. So suppose here this is associated with what? This is associated with these 3 rows. This is associated with these 3 rows. First row is associated with these 2. Second row is associated with these 3 rows. Second row is also associated with 3 rows. The third row is also associated with the 3 rows. All the rows in first table linked to all the rows in second table. Okay, na? What this relationship is called? Many to many. That's so there are three types of relationships exist between two tables. One to one, one to many. Next one, many to many. Okay, na? Then understood. Then one to one to many to many. So three types of relationship exist between the tables. Okay, then. But what is the default relationship? By default. By default, what type of relationship is created between the two tables? See this example. Huh? Between the two tables, what type of relationship is created? One to many. See that 100 project is 100. How many employees working for this project? 100. 2 employees. 100 project is one, na? One project. How many employees? Many employees. 2 means many. One project, many employees. What is the relationship? One to many. Okay, na? One project, many employees. One to many. So here by default, foreign key allows duplicates or not? Yes or no? Yes. If foreign key allows duplicates means what type of relationship is created? If foreign key allows duplicates, boss, if foreign key allows duplicates, what type of relationship is created? One to many. Okay, na? Then, so if we want to, but I want to establish one to one. Suppose there is one table is there. Between the two tables, I want to establish one to one relationship. So if you want to establish one to one relationship, then what you do? You want to establish one to one relationship. To establish one to one relationship, then what you do? Sorry, here, just this is only simple. Okay, now then see here it is allowing duplicates now. If you allow the duplicates, what happens? One to many. Don't allow the duplicates. If you don't allow the duplicates, one to one is created. If you allow the duplicates, one to many. If you don't allow the duplicates, one to many. So one project, one employee. Suppose one project, one employee. Don't allow second employee. If you don't allow the second employee, one to one is created. If you allow the second employee, one to many is created. Yes or no? Then how to not to allow the second employee? Don't allow the duplicates into Foreign key. How to not to allow the duplicates into foreign key. So declare foreign key with what, sir? Unique constraint. Declare foreign key with what, sir? Unique constraint. If foreign key declared with unique constraint, then duplicates are not allowed. Then what is created? One to one is created. If you allow the duplicates, one to many. That's all. Okay, na? Then so now by default, what's it? By default, SQL server creates one to many relationship between two tables. Okay, na? Then next. So then question is what's it? How to establish what? One to one relationship. Okay, then how to establish one to one relationship. Then so to establish what? To establish one to one relationship. To establish one to one relationship. Declare what? Declare foreign key with what, sir? Unique constraint. To establish one to one relationship, declare foreign key with what, sir? Unique constraint. Okay, now then that's so. What is the example? Any example? One to one. This is project employees example for you take in real time also. Then project and employees example for project and employee example for one to many. Yes or no? One project, many employees are one employee. Many employees works for one project. So relationship is one to many. Like that, tell me one example for one to one. Okay, na? Example for one to one relationship. Then what? Hmm? Example for one to one. Hmm? PAN number, employee ID. Employee ID, PAN number. Sir, here, employee ID, you said PAN number. Relationship does not exist between the fields. Relationship exists between the tables. You're telling fields. MPID is one field. PAN number is one field. Relationship does not exist between the fields. Relationship exists between two tables. Then again you are saying same thing. What I'm saying, ID is field. Name is also field. Sir, every employee having only one name only. Always. Okay, na? Then one ID, one name only. Then that is not one to one. Okay, na? Tables between the two tables. Understood? Then, sir, department is there. Companies department. There is a 10th department, HR department, 20 department, IT department, 30 department, sales department. Yes. Department employee. What is the relationship? Department employee. What is the relationship? Department employee. One department. I'm asking the relationship between department and employee. Huh? One to many. One department, many employees. One department can have many employees. What is the relationship? One to many. Department manager. Department manager. One department managed by one manager. One manager manages one department. So what is the relationship? One to one. Okay. Manager number, manager name. So manager is one, name is A, manager two, name is what, sir? B. Manager three, suppose manager three C. So one department is managed by one manager. One manager manages exactly one department. So relationship between these two tables is 1 to 1. First establish the relationship. First establish the what, sir? Relationship. Then to establish the relationship, add what, sir? Foreign key. To which table you add foreign key? To which table you add the foreign key? I'm asking, see, first you have to establish the relationship. To establish the relationship, add foreign key. To which table you add foreign key? Any table. Any table. If it is one to many, if it is one to many, always you have to add foreign key to many side table. One to one, any table. Okay. So I'm adding foreign key to manager table. I'm adding foreign key to manager table. So what is the foreign key in manager table? Add foreign key to manager table. What is the foreign key in manager table? Department number. Yes or no? What is the confusion, boss? Department table primary key. Take the primary key of department table, add it to manager table. In department table, department number is primary key. Manager's table, department number is foreign key. Suppose add foreign key to department table, then manager number. That's all. Take primary key of other table, boss. That's all. Then but suppose I want to add foreign key to manager table, then department number. So how to declare the foreign key? References plus what? Department table. Which column? Department number. So declare the references. Okay. Plus if you declare only foreign key, then one to many is created. But now here what? One to one. So to establish one to one, then one more. What is that is? Unique. That's all. So foreign key plus unique makes one to one relationship. Only foreign key. Only foreign key. One to many. Foreign key plus unique. One to one. Then. So like is the manager for 10th department. Is the manager for 20th. Suppose again I enter 10. Again I enter 10. Allowed or not allowed? Not allowed. Because unique is then. Unique will not allow the duplicates. Yes. Now next. Suppose 30. Allowed. So one department, one manager. One manager is managing one department. So relationship is 1 to 1. That's all. Okay. Understood then. Next. What is the next one? Huh? How to establish what, sir? Huh? How to establish what? Many to many. Sir, only actually four, but these two are same na. One to many or many to one. Always foreign keys added to many side table. Understood? Then what? Many to many. Many to many. Then. So what is the example for many to many? Hmm? What is the example for many to many? Project employee. Yeah. Project employee, project employee, one to many, one project, many employees. One employee cannot work for many projects. One employee can work for many projects. No, one project can have many employees. One employee works for one project. So what is the relationship? Project to employee. What is the relationship? One to many. Okay, then. Example for many to many. Hmm? Uh, uh, Many subjects, faculty subject. One subject can be taught by many faculties. Yes or no? Yes. Okay, na? Another one, what's that? Student. Student and what's that? Student ID, student name. Suppose you take what's that? Course ID, course name. You take university. You take university. What is the relationship between student and course? What is the relationship between course and student? What is the relationship between course and student? University. Uh, one course can be taken by many students, but one student register for one course, but one course can be taken by many students. So what is the relationship? Course to student bus. One course, many students. What is the relationship? One to many. One to many. Yes or no? Then student to two course. Student to two course. Many to one. Many student joins for one course. Many to one. Yes or no? Then. So here that is in university. Now Amir paid. Hmm? What is the relationship? One student joins for many courses. One course can be taken by many students. What is the relationship? Many to many. Here, one student joins for what? Here, one student joins for many courses. One course can be taken by many students. What is the relationship? Many to many. That's all. Okay, now this is the example for many to many. Okay. So student one, what's that? Student A, student two, B. Suppose course 10, for example, course 10. Suppose what? Some .NET. Course 11. Then what's that? SQL. Okay, na? Understood. Then there are two tables. What do you want to do? You want to establish the relationship with two tables. But what type of relationship you want to establish? Many to many. So, okay, na? Then how to establish the many to many relationship? To establish the many to in both previous examples for one to many, what you did for one to many, what you did added what's the foreign key. So if it is one to one, you added foreign key to any table. One to many, you add foreign key to many side table. Yes or no? But for many to many, you cannot add foreign key to any table. Understood? These are the rules. One to one, any table. One to many, many side table. Many to many, you cannot add foreign key to any table. You can't add foreign key to student table. You can't add foreign key to course table. Then how to establish the relationship? To establish the relationship, what it says, create third table. Create what's it? Third table. So in third table, what you store, like let's say registration. In third table, take primary keys of both the tables. Take what? Primary keys of what's that? Both the tables. What is the primary key in student table? Student ID. What is the primary key in course table? Course ID. Course ID, like let's say date of registration. What is the fee paid by the student? Like this. Sir, understood or not? So between these two tables, I want to establish many to many relationship. To establish the many to many relationship, create what's it? Third table. In third table, take primary keys of what? Both tables. Like student 1, join for course 10. Student 1 can join for another course. Yes or no? Yes. Student 1 join for course 11. Student 2 join for course 10. Possible or not? Yes. Student 2 also join for course 11. Possible or not? Yes. Student 1 associated with how many courses? 2 means many. And course 10 is associated with how many students? Many. So what is the relationship between student and course? Many to many. Then, sir, one to one, add foreign key to any table. One to many, many side table. Many to many, create new table. Create third table. In third table, take primary keys of both the tables has foreign keys. Understood? Then, okay. Okay, then. So we'll continue this tomorrow. Ah, mm, then. Here, no. Composite primary. Composite primary. We'll see that.